So it says a block of mass 2 kilograms is at rest on a horizontal rough surface. Before I carry on with this question, I have to say you need to make sure you can do these questions with the tension and the strain between the two objects because it is very popular at the moment. Science, if you can believe it, goes through different types of trends, and at the moment the popular question out of all the questions is this type of question. So please make sure you can do these type of questions. Right, so let's go back to it. We've got a block, mass 2, on a rough horizontal surface. The block is connected to another block of mass 1.5 kilograms by means of a light inextensible string, big word for not stretchy, which hangs over a frictionless pulley. The 2 kilogram block experiences a constant frictional force of 3,1 newtons, okay, when a force of 20 newtons is applied to the block, as shown in the diagram. Ignore the effects of air friction. Yay! Now it says define the term kinetic frictional force. Basically, this is the frictional force that an object has when it is moving. Okay, go and learn your definition properly. Then it says draw a labeled free diagram indicating all the forces acting on the 2 kilogram block. Okay, so free body diagram is a dot. And what do they want? They want all the forces. And here's your hint. There's 5 marks, so should be drawing 5 forces. So let's think about it. Do you agree that we've got the applied force of 20 newtons? There is the force of gravity and the equal and opposite normal force, F normal. There is the tension in the string. Yeah, that there. And we've got the force of friction, the force of friction. 1, 2, 3, 4, 5. There we go. We sorted. Now it says apply Newton's second law, which is F net equals mass times acceleration, to each of the blocks and calculate the magnitude of the acceleration of the blocks. Okay, so here's your hint, the fact that you have to apply to each of the blocks. Okay, so let's just draw the free body diagram from this dude as well. So if we do that, the free body diagram here is going to be the force of gravity here and the tension up. And do you agree that this tension here is equal to this tension here? So yeah, they've been sneaky. They haven't asked you to draw 2 free body diagrams so you could realize that that tension is equal to that tension, okay? They've actually made you try and realize that you need to do it by saying that you need to apply it to each of the blocks. So we also know that this object is accelerating. They're both accelerating. And they said calculate the magnitude of acceleration of the blocks. They're both accelerating with the same magnitude. So if I had to look at this guy and I wrote out my formula for Newton's second law, do you agree that F net, which equals mass times acceleration, would equal the sum of these forces, which would be T plus the force of gravity. Remember, I'm not allocating directions yet, okay? If I had to draw the thing here, the F net equation for this dude, I'd be going F net is equal to 20 plus T plus the force of friction. Again, I'm not allocating direction yet. I'm just giving you an idea of the fact that we need to use these 3 forces to work out the net acceleration, and I need to use these 2 forces to work out my net acceleration here. But these net accelerations are the same. The net forces are different, but the accelerations are the same. Okay, so then, do you agree I can say 1, 5, and I'm going to choose right as positive, okay? And then therefore, if this is right is positive, then up is going to be positive here, because if that goes right, then this is going up, okay? So 1.5a is equal to T minus the force of gravity, which is going to be 9,8 times the mass of this, which is 1,5, okay? So do you get, I could solve this equation for T. So I could say 1,5a plus, and let's pop this in a calculator, I've got 9.8 times 1.5 is equal to 14.7, 14,7, and that is equal to T. Right, Now I can say, work with this one. And I can say the net force is the mass of this object, which is 2, times by the acceleration of A, is equal to 20 minus T, because 20 is in the opposite direction, minus the force of friction, which they've given us is 3.1. Okay? So therefore we can say, and I'm going to write a V because I need the space, 2A equals 20 minus T, but T is this bit here, so I'm going to fill it in. 1,5A plus 14.7, and please remember your brackets, otherwise you're going to get this wrong, minus 3,1. So now I'm going to get everything that is an A onto the other side, and everything that's a number is going to stay on the one side. So this becomes 2A is equal to 20, let's multiply out this bracket first, minus 1,5A, minus sums of pluses, minus 14,7, minus 3,1. Take that across, it becomes 2A plus 1,5A is equal to 20 minus 14,7 minus 3,1. So therefore we've got 3,5A is equal to, and just let's do that on a calculator. So we've got 20 minus 14.7 minus 3.1 equals 2,2. So that's 2,2. Therefore A is 2,2 divided by 3,5, which equals, divided by 3,5 equals 0,63. So that's 0,63 meters per second squared. And it is to the right because it's a positive value, but you didn't need to say that because they just say calculate the magnitude. That's actually a very nice question in grade 12s.